Welcome to yet another solution video of Mathematics 3 of A-Level Cambridge International, paper 33, May-June 2022. If you like this video, please share with your friends and subscribe to Math United. Thank you very much. Question number 1. Find in terms of A. This is important. In terms of A, that means they don't want a number, perfect number. The set of values of x satisfying the inequality this and where A is a positive constant. Okay. Now look, this part has a modulus part and this is also a modulus part. It means that if we draw a graph of both of them side by side, one of them will have a greater gradient. Suppose this is the steeper gradient, and one of them will have lower gradient. Suppose this is one. So this is always true that the one which has lower gradient will always intersect the one with greater gradient as two parts. Okay. So if the question is such that the greater gradient in this, let's write this one first. It is, if I open the brackets here, it becomes 6x plus 2a, and let's make it a different function. So I make this one as a different function and this will become another function, y equal to plus or minus 2x plus 3a. We are not sure whether inside these modulus they are positive or negative, that's why we wrote both of them. But what is important here is that we know that both of them will have final value will be positive above x-axis, and the one with lower gradient will intersect the one with higher gradient at two places, right? Now, this has higher gradient. Can you see? 6 is a higher gradient, right? And 2 is lower gradient. It means that this graph will intersect this graph at two places, right? And here they're saying it is lower. Yeah, that means the one with the higher gradient has to be lower than the one with lower gradient. So that means this will be your answer, where the higher gradient graph is below the lower gradient graph, right? So somehow if we find their points of intersection, we'll just write that the answer is between those 2 points. Okay, so let's find their points of intersection, these 2 points of intersection. Okay, so for that, what will we do? We will convert one of them as 3x plus a. A normal expression is less than, no, rather we are trying to find root, right? So not less than, it is equal to, we want points of intersection. Now this one we will write once plus 2x plus 3a, and once we will write this as minus 2x plus 3a. Now some of you may wonder, why the right side, why not the left side? So it doesn't matter which one you change the sign, because if we take plus plus or minus minus on both sides, this minus cancel, they again are same as both pluses like this. And if we take plus minus and minus plus on left and right side, they are exactly same, which represent this one. So out of 4 combination, these 2 are the ones we have decided. It does not matter where you put this minus, you can put here also, doesn't matter. So let's see points of intersection. 6x plus 2a equal to 2x plus 3a. Since a is unknown, that's why we don't know what are the values here, and we are not interested in that also, because we want to solve the inequality in terms of a. So 6x minus 2x, put x's together, and 3a minus 2a. So it becomes 4x equal to a, and x becomes 1 over 4a. Similarly here it will be 6x plus 2a equal to negative 2x negative 3a. So 6x plus 2x equal to negative 3a minus 2a. 8x equal to negative 5a. So x here comes out to be negative 5 over 8a. So we got the 2 points of intersection. The lower one, which one is lower out of these two? One is coming out to be positive, 1 over 4a, Yeah, it's positive 1 over 4a. That means this is 1 over 4a, this point of intersection. The second one is negative 5 over 8a. And since a is a positive number, definitely the positive will be bigger one and negative will be smaller one. So our answer is the one which is below in higher gradient graph, and this will be your answer will be between minus 5 over 8a. X is between these 2 points of intersection for sure. Question 2. Solve the equation this compound angle equal to 3 sine theta, and our answer should be between 0 and 360 degrees, which is good. Okay, so let me write down the question again. Cos theta minus 60 equal to 3 sine theta. Their angles are different, so first thing should be that their angles must be made same, and that will be done when I open this compound angle identity with this one. Cos A minus B is equal to cos A cos B minus, rather plus, it's negative here, plus sine A sine B. So it will be cos theta, which is cos A for us here, cos 60 plus sine theta sine 60 equal to 3 sine theta. Now we can evaluate cos 60 and sine 60. Cos 60 is half, so half cos theta plus sine 60 is square root 3 over 2 sine theta equal to 3 sine theta. So now this is sine theta and this is sine theta. We can combine them and leave the cos theta on the left side. Half cos theta equal to 3 sine theta minus square root 3 over 2 sine theta. Okay, can we take sine theta common from these two? Yes, we can. So let me do that. What is left? 3 from the first one and square root 3 over 2 from the second one. And here it is half cos theta. Okay, now the angles are same, but the ratios are different. And we can make them one ratio. Whenever you have sine and cos on two sides of an equation, always divide by cos. Why? Because we know that sine over cos is tan, and the cos will go from here. So what are we left with? Half equal to 3 minus square root 3 over 2 tan theta. And now we will divide this by 3 minus square root 3 over 2, and this also 3 minus square root 3 over 2. So that this is gone from the left side, and we are left with this, where theta will be tan inverse half divided by, I'm sorry, this was not full, 3 minus square root 3 over 2. This was not complete, right? Can you see here? This 2 was below only square root 3, right? So now half is positive and 3 is definitely bigger than square root 3 over 2. That means this whole bracket will be a positive one. So where is the tan positive in quadrants? If we know tan is positive in first quadrant and the third quadrant, right? So if you put tan inverse this, because it's positive, definitely we're going to get an acute angle. So just put this very carefully in your calculator. Don't make a mistake like me. I did here the full line, and you will get an acute angle. Let me try it myself. Tan inverse 1 over 2 divided by square 3 minus square root 3 over 2. Okay, so what do I get? I get theta equal to 13.1867. okay, many digits more. So which we can round off to 13.2. 3 significant figures. degrees. So 13.2 here and 13.2 here. So what are the two angles then? The first angle will be this one only, which is acute itself. The first answer is 13.2 itself. And the second will be from here to the line, which is 180 plus 13.2, which is 193.2 degrees. This is the second answer. Okay, let's go to question number 3, which is here. Show that the equation, this can be written as a quadratic equation. Of course, it can be. So let me rewrite it here. 2x plus 1 equal to 1 plus 2 log base 3x minus 1. So if they are saying we have to convert it to quadratic, that means these logs must go. For logs to go, they should be on one side. So let me put this log to the left side again. So log base 3 2x plus 1 is already here. And then I'll bring minus 2 log base 3 x minus 1 also to the left side, which is equal to 1. Now these log must be combined so that we can get rid of logs later. So I cannot combine this log and this log unless this 2 is taken care of. And according to logarithmic law, this coefficient can become the exponent of the content. So I can do that one, and then it will be easier for combining those logs. 2x plus 1 minus, I'll keep the minus sign, only 2 will go and become the exponent. Done. Now we can combine these two logs because they are of same base, and whenever two logs subtract, you might have heard of this one, log a minus log b equal to log a divided by b, and that's what we're going to do now. So log remains log base 3, 2x plus 1 becomes numerator, and x minus 1 whole square becomes denominator, which is equal to 1. Now we can remove this log. Whenever we remove log from one side, let me remove first. When we remove log from one side, the other side becomes the exponent of the base. So if it was natural log, it becomes e to the power. If it is base 10 or nothing written, it has become 10 to the power. But here the base is 3. So it becomes 3 to the power 1. And now log is gone. We can simply convert it to quadratic equation by cross multiplying this here. So 3 remains 3 there. X minus 1 square comes and multiplies with 3. So let's open the bracket on the right side first, and then we'll take care of it. So x minus 1 square, we will use a minus b whole square is a square plus b square minus 2ab. So it becomes a square plus b square minus 2ab. So 2x plus 1 is 2x plus 1, no change. 3 will multiply with x square, becomes 3x square plus 1 square is 1. So 3 multiplied by 1 is just 3. 3 multiplied by 2 is 6 minus 6 and x. So let's write the final thing here. We want it to be quadratic. So let's bring 2x plus 1 also to the right side. So 0 remains on the left side now. 3x square is already here. Plus 3 and minus 6x. And we get 2x plus 1 from the left, which becomes minus 2x minus 1. So 0 equal to 3 x square minus 6x and 2x, 8x. 3 minus 1 is 2. This is the quadratic equation they were looking for. Can be written as quadratic equation into x. We've done that. Okay. Let's see what is the second part. Hence, solve equation same base 3 and similar looking question. If you compare it with the original question, only difference is that 2x has become 4y and x has become 2y, basically double of this. So our answer is this one, right? This one. Here we will substitute x by 2y. Let's do that one. Let me do here. It means that every x is 2y for us. Okay. So in this, we will just substitute x by 2y. So it becomes what? 3 2y square minus 8 2y plus 2 equal to 0. So 2 remains 2, okay? There's no x with 2. So what is this? 3 times 4. 2 square is 4 because square is over both. So it will become 4y square inside. Minus 16y plus 2 equal to 0. This becomes 12y square minus 16y plus 2 equal to 0. All are even, so let's divide the whole equation by 2 so that it becomes simpler for us. So it becomes 6y square minus 8y plus 1 equal to 0. And this is our new quadratic equation which we have to solve, giving an answer in 2 decimal places. That means we'll have to use quadratic formula in this because factoring is not possible. Okay, our quadratic formula is minus b plus minus square root b square minus 4ac over 2a. That will be y in this case. So y is minus 8. Yeah, this is b, this is a. So plus minus square root minus 8 square minus 4 times a. A is 6, c is 1, positive 1, that is, divided by 2 times 6. Okay, let me complete the whole process now fast and I'll get to you with the answer. So this one came out to be 1.1937 and they're saying to 2 decimal places, so which will be 1.19 and this comes out to be 0.1396 which will be 0.14. Okay, but let's see if it works for the log, because this is a case of logs. In logs, not every answer works because we cannot have a log of a negative number or 0. Log 0 is undefined. Log negative something is undefined. So these two cases cannot be accepted. So let's look which one is giving us negative or 0. Obviously this is positive, so 4y plus 1 will be positive and 2 times that, and it is much more than 1, right? So is 2 times 1.19 greater than 1 so that we get positive? Yes, it is. So this works in both cases. 0.14 will work here, that's fine. And it will not work here because 2 times 0.14, and this is minus 1, right? It has to be greater than 1, is less than 1. And this will give us a negative expression. That means 0.14 does not work for us. We will have to get rid of this. This is inadmissible. All right. What's question number 4? The curve y equal to e to the power minus 4x 10x has 2 stationary points. Good. But in this interval, 0 to pi by 2. Okay. Here. Obtain an expression for the derivative of this function and show it can be written in this format. A and b are constants. Okay, so let's straight away try to differentiate this. So dy over dx. So we can see that e to the power minus 4x has a variable x and 10x also has a variable x. That means 2 variables are multiplying. That means we can use the product rule. Okay, so what does product rule say? UV prime is U prime V plus U V prime. So the first one will be differentiated first. So e to the power minus 4x will be differentiated and v tan x will remain tan x. So if I differentiate any exponential, first we copy it and then we differentiate its exponent, which is minus 4x. So if I differentiate minus 4x, it's negative 4. So this will be multiplied with negative 4 and tan x remains tan x. Now we have to keep u same. E to the power minus 4x will remain what it is and tan x will be differentiated, and differentiation of tan x is secant square x. Now they're saying it can be written in this format. If you see, there is a bracket here and e to the power minus 4x and secant square x are taken common outside, and that's what we will do first. We will not look what is the look of this. We will take them common because we have e to the power minus 4x and secant square in one of them. So let's take, they have taken secant square in front and e to the power minus 4x in back. It's okay. We can take both of them together also, doesn't matter. So this second one, the whole of it is outside, so it will be plus 1. Here we have e to the power minus 4x, that's okay, taken out. So minus 4 is remaining here. And now tan x. But it does not have secant square x, right? So whenever we have taken something out but it is not part of it, write the one which is there and divide it by what you have taken outside. So now if I open it, you will see that this times 1 will give me this term. If I multiply this, it will give me this first term because secant square x and secant square x will get cancelled out and we'll be left with what we started with. Now, so we have something out and something inside, but it is not matching with this. So we'll have to do something. Let's focus on only bracket and then I will write it. So 1, okay, a is there, a constant. Let's assume that it is 1. So let's simplify only minus 4x, minus 4 tan x. So tan x is sine x over cos x, correct? Secant square will be 1 over cos square x. Can I write this as minus 4 sine x over cos x, which is numerator, divided by 1 over cos square x, because fraction inside a fraction sometimes confuses. So I can write this way. So I'll write the simpler form now. 4 sine x cos x multiplied by, whenever a division becomes multiplied, the rational number after that is reciprocated. So it will become cos square x divided by 1. And now this cos x will cancel with 1 of the cos x and we are left with what? Minus 4 sine x cos x. Right? Now, if you know there is an identity that sine, because we want sine 2x, right? So sine 2x is 2 sine x cos x. Correct? So can I write this one as minus 2 times 2 sine x cos x? And 2 sine x cos x is sine 2x. This minus 2 will be in front. So let's write this now properly. E to the power minus 4x secant square x was outside. 1 matches with a, so let's write 1 because I did not look at it. I just simplified this and this became minus 2 sine 2x. Yeah, because this is sine 2x. So minus 2 sine 2x. And now we can compare with this one. A comes out to be 1, yeah, and B is minus 2. Okay, what about B part? B part says, hence, find the exact x coordinate of the two stationary points. So let me write e to the power minus 4x secant square x 1 minus 2 sine 2x. Okay, so for stationary point, first derivative dy over dx has to be equal to 0 because dy over dx is the gradient of the tangent, and at turning point It is always horizontal and its gradient is 0. So dy over dx, which is gradient, has to be equal to 0. And dy over dx we got e to power minus 4x and secant square x 1 minus 2 sine 2x equal to 0. This was the dy over dx which we made equal to 0. Now it has three parts multiplying this, this and this. When something multiplies and it is equal to 0, that means one of them is equal to 0 or two or all of them are 0. Let's see which one could be equal to 0. E to power minus 4x, can it be equal to 0? E to power nothing. E is a number, right? E is a constant. Its no power will ever give you 0. If you know e to power minus 4x graph will something look like this. So it will never reach the 0 level. So no, this cannot be 0. Secant square x also cannot be 0 because secant, if we ignore square because square will make it a larger value, the graph of secant is something like this. It is outside 1 and minus 1. It is never ever 0, never ever 0 here at this level. And if you're not sure, you don't know this graph, you can do this way. 1 over cos square x, because secant square is 1 over cos square x equal to 0. Make it cross multiply. 1 is 0. Is 1 equal to 0? No. So that proves that this will not give us any solution. This will not give us any solution. That means this is the only one which is going to give us any solution. And let's try to solve it here. 1 minus 2 sine 2x is equal to 0. 1 equal to 2 sine 2x divide gone. So 2x is equal to sine inverse half. Okay, it's positive, half is positive, and sine is positive in first and second quadrant. They have given us a condition that is between 0 and pi by 2, right? But don't worry, because of this 2x, we will come back to this quadrant. So what will be the first answer? 2x equal to sine inverse half is pi by 6. You can use your calculator. Pi by 6. So first answer is pi by 6. This will also be pi by 6. But we will have to look from 0. So this is the second answer. That will be 2x equal to pi minus pi by 6. So here if I multiply divided by 2, x is pi over 12, and here 2x equal to 6 pi minus pi, 5 pi over 6, again divide by 2. So x is equal to 5 pi over 12. These are the two answers which are both smaller than pi by 2, and that's why both are acceptable. Alright, question number 5 is about complex numbers. 3 minus I is denoted by U, okay? Show on an Argand diagram with origins O the points A, B, C representing these three: U, U star, which is conjugate, and the difference of the conjugate and the complex number itself. Okay, so let me try to draw as clean as possible. This is real, this is imaginary. Real and imaginary axis. Okay, the first one is U, which will be represented by A, and U is 3 minus I. The real part is 3 and imaginary part is minus 1. So let's write here 1, 2, 3. This is real and minus 1 somewhere here. So this point here, whose 3 minus I, this is point A. Okay, next, second one, U star, which is conjugate of 3 minus I. In conjugate, the sign of the imaginary part changes. So 3 plus I. So 3 is already here, plus I on opposite side of this, so this will be B. Next is u star minus u, that means conjugate 3 plus I minus u, 3 minus I, that is u star minus u. So it will be 3 plus I minus 3 plus I. 3 and 3 cancel, 2I. So 2 imaginary parts. So this is 1 and this is 2. This is C. Okay. Anything else? No. State the type of quadrilateral formed by OABC. So let me connect OABC. This is O, the origin. So OA first. Okay. OA. Then B. And then C. Okay. Clearly we can see that the size of the side here is 2, and they're parallel, right? Similarly, it is this direction is 1 down and 3 to the right. This also 1 down and 3 to the right. That means these lines are also parallel. So these are parallel, these are parallel, and of course their size is also equal. 2 sides are parallel. So quadrilateral or OA, let's write quadrilateral OABC is a parallelogram because AB is parallel to OC and CB is parallel to OA. That's why it's a parallelogram. Okay, there is next part also. What says? Express conjugate over u in form of x plus iy. Okay, I was expecting something challenging here. I don't think this is. So u star over u will be 3 plus I. Yes, 3 plus I is u star. And u is 3 minus I. And we have to express in x plus iy format. That means we have to rationalize the denominator, and for rationalizing we multiply by the conjugate of it, of the denominator. Okay, not the conjugate of conjugate in this case. So whatever we multiply down, we have to multiply by the same number on top also. So this is how it will be. And now we can write, this is a minus b, a plus b format. There is an identity, a minus b, a plus b is equal to a square minus b square. This is a very famous identity which we are going to do and use straightforwardly. So let's do it. A square means 3 square minus I square, a square minus b square. But for this we can use the one a plus b whole square, which is a square plus b square plus 2ab. So here a is 3, so a square plus b square plus 2ab. So what will that be? 3 square is 9, I square is negative 1, and 6i. Third one, then we have 9 minus 1. Yeah, I square is again minus 1. So it will be how much? 8 plus 6i divided by 9 plus 1, 10. So finally we can write this as 8 over 10, because they want x and y are real, so we have to separate them, plus 6 over 10. Let's write I here. So 8 over 10 can be written as 4/5. So 4 over 5 plus I 3 over 5. This is the x plus iy format. Okay. What about the next one? By considering the argument u star over u or otherwise, prove that tan inverse 3 over 4 is equal to this. Okay. So let me show, this is u star over u, which we got earlier. So u star over u is this. So first of all, you should know this one. So argument u star over u is same as argument of u star minus argument of u. Okay, so first let's find the left hand side, LHS, argument of u star over u. So if we it is already, we know this, tan inverse the imaginary part, which is 3 over 5 divided by 4 over 5. Both have same denominator, cancels out, so it comes out to be tan inverse 3 over 4, which is our left side here, right? If you want to see it visually, you can see it this way. The real part is 4/5, so not even 1. Okay, let's say this is 1, so 4/5 will be somewhere here, and imaginary part is 3/5 positive. So suppose this is 1, so 3/5 will be here, so here. So this is 4/5, this is 3/5, and that's what I've done. Opposite, this is the argument, right? So 3/5 divided by 4/5, I've done it directly, because this is the direct formula for argument of any complex number, tan inverse imaginary part divided by the real part. Okay, let's go to the other one, argument of u star. Okay, u star was here, if we remember, this was 3, 1, 2, 3, and this was positive 1, that was u star. So what will be the argument of u star? This one will be tan inverse, and if this is the argument, opposite is 1 over adjacent is 3, right? Now what about this? It was in this direction, u. It is again 1 downwards, and this is 3, this one, but it is in opposite direction, right? So minus tan inverse 1 over 3, but this minus is because of this minus. Because it is in the opposite direction, we have to put a minus again. That's a negative argument. It's in opposite direction, so it becomes how much? 2 tan inverse 1 over 3, and they are equal. This is what they were showing, asking us to show. Tan inverse 3 over 4 is equal to 2 tan inverse 1 over 3. So for left side, we found the argument of u star over u directly. For right hand side, because of this identity, we found them separate, and they came out to be exactly same but in opposite direction. Because of negative, they added, we got this. Moving on to question number 6. The parametric equation of a curve is this: x is in terms of t and y is also in terms of t. That's why it's called parametric equation. T is the parameter, where t is between 0 and pi by 2, first quadrant. So it is in first quadrant here. Okay, show that the differentiation of this parametric equation, set of parametric equations, is this. All right, so dy over dx, we want to find out. It can be written as dy over dt, because y is in terms of t, and multiplied by dt over dx. Yeah, so if we find dy over dt and dx over dt, we can simply find dy over dx. So let's find dy over dt by differentiating y with respect to t. So the first one, this first equation, y equal to natural log of tan t, is to be differentiated with respect to t. So dy over dt will be, whenever there is a natural log, we reciprocate what is the content, 1 over tan t is the first part. Then we differentiate what is the content of the natural log, and differentiating tan t will give us secant square t. Our dy over dx is in terms of cos and sine, so let's convert them to cos and sine. So 1 over tan t will be 1 over sine t over cos t. Yeah, reciprocal of this multiplied by 1 over cos square t. So since it's a reciprocal, I can write this one as cos t over sine t multiplied by 1 over cos t, so cos square t. This cos t and one of the cos t cancel out, so 1 over sine t cos t. This is dy over dt. Okay, let's move on to dx over dt by differentiating the second equation by differentiating this one with respect to t. So dx over dt, the first one, it is 1 over cos t. First of all, it could be, if I write 1 over cos t, it can be written as secant t, right? And dx over dt, did I write y? No. Differentiating x equal to 1 over cos t with respect to t. So dx over dt will be, first of all, I can write this as secant t, isn't it? This 1 over cos t is secant t, and differentiating secant t will be secant t tan t. Again, I want to convert it to cos and sine, so it will be 1 over cos t secant t, and tan t will be sine over cos t. Okay, this is simplified form will be sine t over cos square t. Now we have dx over dt, we have dy over dt, and now we will use this relationship. So dy over dx will be dy over dt first, 1 over sine t cos t. And multiplied by dt over dx, not dx over dt. That means we have to reciprocate this one to multiply with this. So it will be cos square will become numerator and sine t will become denominator. Again, cos t will cancel out with one of the cos. So cos t is the only one left on numerator, cos t. And sine t, if they multiply, it becomes sine square t. And compare it with what they wanted us to show, it is exactly same. Okay. Next. Find the equation of tangent to the curve at point where y is 0. So y is confirmed 0. So we need to find x also. So x, they gave us what was x equal to? Let me check again. 1 over cos t, and y was ln tan t. Okay. So t is the one that is connecting the both. So let's find t first so that I can write 1 over cos t. It was here. So y was ln tan t. Let's find t with the help of this y equal to 0 so that we can substitute it here and we find x, and then we can find the equation of the tangent. So 0 equal to ln tan t. Okay, and we should know that if a log, any log for that matter, if it is equal to 0, that means it is the content is equal to 1. So let's make tan t equal to 1. Let me repeat. Whenever a log is equal to 0, that means the content of that log is equal to 1, because log of any base 1, let's write p here, any base is always 0, doesn't matter what is the base. So that's what I'm doing here. So the content is 1, I'm writing it equal to that. So t is equal to tan inverse 1, and t will be, since they have already given us the domain for t, let's see, what was it? It was between 0 and pi by 2, first quadrant only, and tan is 1 for only one value, that is pi by 4 in first quadrant. Okay, so got it. Let's find x with help of this one. So x equal to 1 over cos pi by 4. Cos pi by 4 is 1 over square root 2. X equal to 1 over, again reciprocal of 1 over square root 2. So denominator for denominator is numerator, x equal to square root 2. So y 0, x is square root 2, and the equation of tangent, equation of rather any line, is y minus y1 equal to mx minus x1. So y1 and x1 are the coordinates of any point on the line, and we know now that on that tangent x is square root 2. So in place of x1 we'll write square root 2, and y is 0. Please never replace this x and y. They are general x and y's. They will remain as they are. Only x1, y1, which is the specific point on the line, is replaced. Now m is the gradient, and gradient is nothing but dy over dx, and we got dy over dx equal to cos t over sine square t in previous part A. So at t equal to pi by 4, yeah, at that point this is t, so we will find dy over dx, which is m in this case, though m we are looking for here, is cos pi by 4 over sine square pi by 4. So cos pi by 4 is 1 over square root 2, and sine pi by 4 is also 1 over square root 2. So this square root 2 will cancel with one of them. We get exactly same situation like this, so which is square root 2 again like this. So we'll put it here, square root 2. So the final equation we get is y equal to square root 2x minus square root 2 times square root 2 will complete 2. This is the equation of the tangent they were asking. Moving on to question number 7. They have given us a rational function rather, and they're asking us to express fx in partial fraction. This is fx for us. So let's write 5 equal to x minus, first of all, denominator here 2x square plus 3 will be equal to a divided by the first factor of the denominator, which is x minus 2, plus second factor is 2x square plus 2. Yeah, so since it's a quadratic denominator, we have to write a linear on top. So we can write here bx plus c, and we have to find a, b and c, so that we can write this as partial fraction. So left side, this one remains same, but the right side will become, the LCM is x minus 2, the denominator of the first one, multiplied by the denominator of the second one. That means this a will be multiplied by this particular denominator of the other one, so that we get exactly same denominator for both. So 2x square plus 2 here, plus bx plus c is already at the numerator, it will multiply with the denominator of the other, x minus 2. Now compare this and this. They have exactly same denominator. This is same denominator. That means we can equate the numerators only. So equate numerator. So first one is 5x square plus 8x minus 3. Right side will be a 2x square plus 2 plus bx plus c x minus 2. Now the first effort should always be to make one of the brackets equal to 0 so that our equation is simplified by assuming a number opposite to what a linear one. This is 2, right? If I assume that x is 2, 2 minus 2 will make this whole thing 0. That's what we should do first. So when x is 2, so replace every x by 2. So it becomes 5, 2 square, 8 times 2 minus 3 equal to a 2 square plus 2. And I'm not writing anything here because 2 minus 2 will be 0. Or if you want, I can write this 2b plus c times 0. And this is gone. That's why I was not writing it, but I wrote it. Now I'm left with this one. Only a is the variable here, which I can find now. 2 square is 4 times 5, 20. 8 times 2, 16 minus 3 equal to bed mass. So we have to simplify the bracket first. 2 square is 4 times 2 is 8. And 2x plus, it is 2x plus 3, not, I wrote 2, all of this, I wrote 2. It will be 11a. So 33 equal to 11a. So if we divide both sides by 11, 3 equal to a. So a comes out to be 3. Now there is no other possibility of making it 0. Whenever there is a square, it will be always positive and it cannot make this part 0. That means this cannot be made 0. We have to think of something else. And that something else should be that we compare the constant part of the left side and constant part of the right side. So compare constants. So it will be minus 3 on the left side, isn't it? Minus 3 is the constant on left side. This minus 3. This has a variable x, this has x squared, so only minus 3. Now if I expand this a multiplied by plus 3 will give me a constant. This will not give me a constant, so I will write just 3 times a. Here bx will not give you a constant, c will give you a constant when it multiplies with minus 2. So it will be minus 2c. Since we know the value of a now, we'll substitute here and we'll get c. So minus 3 equal to 3 times 3 minus 2c. Minus 3 is equal to 9 minus 2c. And what does that give me? If 9 goes the other side, minus 3 minus 9 equal to minus 2c. And rather let me shift it to the upper side so that I can solve it here. Okay. So minus 12 equal to minus 2c. So c, divide both sides by minus 2. 6, positive 6, that is c. We got c also. What next? Let's compare the coefficients of x. Okay. So the coefficient of x here is 8. So I can write compare coefficients of x. So we have 8 on the left side. Will this give me x square? X? No, it will not, because it is x square. Will this give me x? No. Will this give me x? Yes. Bx will give me x when it multiplies with minus 2. So minus 2b, and x is the 1. C will give me x if multiplies with x. So cx plus c. I'm not writing x because I'm writing coefficients only. So now we know c, so we can substitute it. So 8 equal to minus 2b plus 6. And let's compare it here. 8 equal to, rather this plus 6 also, I can bring it to the left side. So it becomes minus 6 equal to negative 2b. 2 equal to negative 2b. Again divide by negative 2 both sides. So negative 1 on the left side equal to b positive because they have cancelled. So we got this a, this b and this c, and now we can write partial fraction. The final answer will be a was 3 x minus 2 plus bx is negative 1x, okay, negative x, plus c, which is c is 6 over 2x square plus 3. And this negative and this positive, they look very odd. Mathematically, we should not write negative first. So let me change the places of negative x and 6 on top so that it looks mathematically correct. So 6 minus x will be over 2x square plus 3. This is the partial fraction for us. So next part of this is hence obtain the expansion of x in ascending powers of x up to and including x squared. So our answer is this one. Let me rewrite that one. 3 over x minus 2. Yeah, okay. 3x minus 2 to the power minus 1. This is what I can write this denominator as plus 6 minus x 2x square plus 3 to the power minus 1. Since we have to expand these two because 3 and 6 minus x are already settled, we have to expand these two up to x square, and that's what we're going to do now. Okay, so keep 3 as it is, this one, and expand this. What is the expansion of 1 over plus x to power n? It is 1 plus nx plus n minus 1 over 2 factorial x square plus something. Yeah, but this is for 1 plus x. Is this 1 plus x? No. Let me rearrange this. It is minus 2 plus x, right? So it is not. Second one, 6 minus x. Is it 1 plus something? No, it is 3 plus 2x square. So both of them are not. So there is a trick to convert them to 1. How about this? Divide this by 3, divide this by 3, divide this by minus 2, divide this by minus 2. Okay, so now it becomes 1. But we can't just do like this. We have to compensate it. So whatever we divide here, we multiply it outside so that they cancel out, but this exponent must be there with whatever you multiply with. Similarly here, we will write minus 2 with exponent minus 1 outside. So what does it become now? Because of this, it becomes minus 3 over 2. 3 was here. Because of this minus 1, it becomes denominator, and minus because 2 has a minus. 1 minus x over 2 to the power minus 1 plus 6 minus x over 3. Yeah, this is minus 1 power, so it becomes a denominator again. 1 plus 2 over 3x square to the power minus 1. And now we will need this for expansion. So minus 3 over 2 remains minus 3 over 2, but we expand this according to the binomial expansion, which is 1 plus nx. 1 is 1, so 1 plus n. N is the exponent, which is minus 1 in this case. X is not x anymore because it has been replaced by negative x over 2. So negative x over 2 plus n is minus 1. Minus 1 minus 1 will be n minus 1. So minus 1 will be minus 2 divided by 2 factorial. Okay, then x square. Again, x is not x, it is x, negative x over 2. We'll have to square it. Plus, okay, 6 minus x over 3. Let's separate them so that they don't confuse with each other. So I'll separate these two. 6 over 3 and minus x over 3 separated so that we can multiply them individually, and we need to expand this also. So 1 plus nx, n is again minus 1 in this case, x is not x, 2 over 3x square is x, 2 over 3x square. Okay, then we need again minus 1, n minus 1, which is minus 2 again, 2 factorial, and 2 over 3x square plus so on. So this x square is going to give us x to the power 4, but we have to stop at x square. That means this part we can ignore. Okay, so only these is left. Okay, let's expand. Minus 3 over 2 times 1 is minus 3 over 2. Now look here, there is one negative here, there is one negative here, there is one negative here. So there are three negatives. Whenever there are odd number of negatives, we write negative. So it will be 3 times 4, 3 over 4 x. Yep. Now negative 1 times negative 2 will be positive 2, and 2 factorial is also positive 2. So they cancel out. We have to multiply only this one with here. So this is negative. This square will make this negative as positive. So just it will be negative. 3 times 1, 3, divided by 2 times 2 square is 4, 8. Yeah, 4 times 2 is 8. Okay. And x square will be x square. Yeah. Okay. Now 6 over 3 is 2. So plus 2 times 1 is 2. Minus 1 times 2 will be minus 2 times 2 third. Okay, 4. Minus 4 over 3. Yeah. X square. Okay. Now minus x over 3 times 1 is negative x over 3. And this negative and this negative will make it positive. X times x square is x cube. Okay, next term is going to be in x cube, so no need to go to that because we have to stop at x square. Alright, so let's combine numbers. Minus 3 over 2, this is the constant part, plus 2. Minus 3 over 4x plus minus 3 over 4x and negative x over 1 over 3. Like we can write 1 over 3. Okay. Then we have negative 3 over 8 x square, negative 4 over 3 x square. 1, 2, 3, 4, 5, 6. There's 6. Okay. Negative 3 over 2 plus 2. 2 times 2 is 4, minus 3, 1 over 2. So their LCM will be 12. So this will be multiplied by 4. This will be multiplied by 3 and 4. So minus 9x minus 4x minus 13 over 12x. Okay, here we have to multiply this by 3, multiply this by 8. So multiply this by 8, multiply this by 3. Minus 9 minus 24. No, 32. Minus 9 minus 32 is minus 41 over 24x square. This is the final expansion of the given question. Question 8. At time t days after start of observations, the number of insects in a population is n. Population is n. The variation in the number of insects is modeled by this, where k is a constant, n is a continuous variable, n is a variable. Okay, it is given that, okay, this may be of some help later on. Solve the differential equation obtaining a relation between n, k and t. Okay, so let me copy this thing first. dn over dt equal to k n to the power 3 over 2 cos 0.02t. first thing first, dn should always be with n and dt will always be with t, and both of them, dn and dt, both of them should be numerator. Here dt is denominator. So bring dt to the right side so that dt becomes a numerator and it is with t. Bring n to the left side by cross multiplying down there so that it looks like this. dn over n to the power 3 over 2 equal to, k is a constant, so it doesn't matter where you keep it, cos 0.02t dt. Everything is like we wanted. dn is a numerator, dt is a numerator, dn is with n, dt is with t. Alright. Now we have to integrate both sides to get the equation relationship between n, k and t. So let me rearrange this one. It becomes n to the power negative 3 over 2 dn equal to, k is a constant, keep it out, cos 0.02 t dt, and we have to integrate them. So here, see, it's a simple exponential expression, so, and that's a variable. With respect to n, we are integrating it, so the exponent goes up by 1 and we divide by the same new exponent equal to k. Integration of cos is sign, positive sign, sine 0.02t, no change in angle, but we will have to divide it by the differentiation, not integration, differentiation of 0.02t, so it will be 0.02, simply t. So with respect to t it is 1, so 0.02 we divide it, and for a formality we will write c here. Let's try to simplify this. Negative 3 over 2 plus 1 will be negative half divided by negative half. So negative, let's put it here, and half means the reciprocal of half because it's a denominator, right? So reciprocal of half will be 2 on numerator, so there is no need to write any denominator. Now let me erase this. Okay. What about the right side? 1 over 0.02. You can use your calculator, it will be 50. So it becomes 50 k sine 0.02t plus c. That's the simpler version. Now they have given an information here, t is 0 when n is 100. So we'll get the value of c because of this information. So n is 100. So minus 2, 100 to the power minus half equal to 50 k sine 0.02 and time is 0 plus c. This 0 will make this angle 0, sine 0 is 0, that means this whole thing is gone. C is this. C is minus 2 divided by square root 100. Yeah, minus half of 100 means it is denominator positive and square root. So it will be how much? 10. Yeah, square root 10 is 10 minus 2 over 10. So negative 1 over 5. Yeah. So let's replace it in the equation we got earlier here. Minus 2n to the power negative half equal to 50k sine 0.02t plus c, and plus c we got negative 1 over 5. But they said we wanted the relationship between n, k and t. It is n to the power negative half, not n. So let's try to isolate n by dividing by minus 2 here, and we divide by minus 2 here as well and here as well. Yeah, so this cancels out. N to the power minus half equal to this becomes positive, so let's put it here, 1 over 10 positive, right? Minus this 2 and 50 cancels, so 25k sine 0.02 t. Okay. Now they wanted a relationship between n, k and t, so let's give it a power minus 2 so that we get a complete n here. And we'll have to give the same power here as well. So n equal to 1 over 10 minus 25 sine 0.02t to the power minus 2. This is where we can stop. Moving on to the B part. Given that n is 625 when t is 50, find the value of k. So we have, oh, I forgot to write k here, 25k. So we will use this situation to find the value of k now. So n is 625, this n equal to 1 over 10 minus 25k sine 0.02 times t is 50, and to the power minus 2. We have to isolate k. Alright, so to isolate k, this minus 2 should go. So again we'll give the same power minus half here and minus half to the other side also. So it becomes 1 over square root 625 equal to 1 over 10 minus 25k sine 0.02 times 50 will be 1. We want to isolate this, so this goes there first. So 1 over 25 is this, minus 1 over 10 equal to negative 25k sine 1. Let's complete it here. 1 over 25, their LCM is 50. Okay, 2 minus 10 times 5 is 50, minus 5 is equal to negative 25k sine 1. We want to isolate k. So this minus 25 will take here and sine 1 as well. So 2 minus 5 is negative 3. 50 is already here. Minus 25 comes here and sine 1 equal to k. So just put this in a calculator and you'll get the value of k. Let me do it myself. By the time I do this, I'll request you to subscribe to my channel, like this video, share with your friends, and motivate me to make many more videos like this. When I use my calculator, I got 0.0028521. So we can write it to 3 significant figures. This is the value of k. What next? Obtain an expression for n in terms of t and find the greatest. Okay, we already found that one, which was this one. Let me copy this and paste it here. Okay, this is the value for n. We got it. Greatest value for n. Okay, for greatest value means they are asking the maximum value, which is can be determined by the stationary point. Yeah, for stationary point, dn in this case over dt has to be equal to 0, and we already have an expression for this, which is here, dn over dt kn to the power 3 over 2. So let's use that one. It is part of this model. So dn over dt equal to k 0.00285. That's what we got. And then n to the power, this is n, and 1 over 10 minus 25 sine 0.02t to the power minus 2, and this whole n to the power 3 over 2, and then cos 0.01t. this is dn over dt, we have to make it equal to 0. 0.00285 cannot be equal to 0, so gone. This can be, so let's try it here. Let me write 1 over 10 as 0.1 minus 25k, it was k, I forgot k again. So 25k, it is 25 times 0.00285 sine 0.002, there is 2 zeros, t, right, to the power minus 3. Now this 2 and 2 will get cancelled and we'll be left with minus 3. This is equal to 0, right? So if it is equal to 0, we'll bring this negative to the other 0.1 to the other side, so it becomes how much? If I multiply these two, I get 57 over 800 approximately, sine 0.002t to the power negative 3 is equal to negative 0.1. And now to get rid of this negative 3, we will give it minus 1 over 3 as an exponent, and here also. So now we will write here sine 0.002t, this one, and because this has gone, we can write here equal to negative 0.1 minus 1 over 3 divided by negative 57 over 800. And if we put in this in our calculator, we'll see that it's not possible. This is coming a very big number, coming out to be a very big number. Let's write, what is that? This thing comes out to be 30.23 equal to sine 0.002t, and that means it is invalid because sine cannot be more than 1. Yeah, so we will not take this one. That means the only option left with us is this, cos 0.002t. Oh, I'm writing every time one less 0, equal to 0. Okay, if we look at the graph of cos, it is 0 at pi by 2 first. Yeah, that's what we will write here. 0.002t is equal to pi by 2, and t is pi by 0.004, yeah, which is 250 pi. This is the time when you have the greatest value. And now we have to just plug this in our n, this particular equation will get the greatest value of n. And let me do that. N equal to 25k. Okay. So n equal to 0.1 minus 25. We got it 57 over 100, 800. 25k, right? Sine, and now 250 pi, and it is power minus 2. Just put this in your calculator and you get the greatest value at t equal to 250 pi, which is equal to 1209.829. If you want to round off to 3 significant figures, it will be 1210. That is the answer for this. Question number 9. With respect to origin, the point A has position vectors 1 plus 5j. Okay, this one. This is origin, and this is A. So whatever is the position vector becomes the coordinates of the head. A is the head in this case. So the coordinates of A become 1, 5 and 6. The vector OA, which is position vector, is, if you want to write in column notation, 1, 5, 6. This is only for position vectors, mind it please. Alright, the vector equation of a line L is this. That means, okay, so let me write again in column notation, 4, 1, 4, 0, 1 rather. There is no J in this. There is I and K only. So this is like this, minus 1, 2, and 3. So this is the point, any point on the line, and the coordinates are given. So this is the fixed point. This is the parameter, lambda is the parameter, and this is the direction vector. This is giving its direction. Okay. So let's see what A part says. Find in degrees the acute angle, between the directions of OA and L. So suppose L is this way. This is L. Okay. So they're asking us to find this acute angle. Let's call it theta. So to find angle between two vectors, we have this formula, the dot product formula. A dot B is equal to vector A, its magnitude, multiplied by the magnitude of vector B cos theta. Okay. So here we have two vectors. OA is one vector and this is the vector. Point cannot be involved in this, only the direction vector. So the direction of L is negative 1, 2, 3, and the direction of the position vector OA is already given to us. So we will just write here in place of this OA vector dot direction vector of L. So let's write it L vector is equal to magnitude of OA times magnitude of L cos theta. And we know most of the things. First, let's focus on the dot product. Whenever we want to write the dot product, do it this way. Write the first vector first. OA is 156 dot. The second vector is negative 1, 2, 3. And just multiply the x component with x, y component y, and z with z, and add them. 1 times minus 1 is negative 1, plus 5 times 2 is 10, 6 times 3 is 18. And why do we do this? Because the angle between x component and x component is 0, and cos 0 is 1. That's why we multiply them. The angle between x and y component is 90 degree. Cos 90 is 0, and that's why we ignore them. We just multiply x component with x, y with y, and so on. So it will be how much? Negative 1 plus 20, 27. So we got the left part. What about magnitude of OA? Let's do that one first. So OA, this 156, it will be 1 square plus 5 square plus 6 square. This is the magnitude of OA, which is square root. 1 plus 25 is 26 plus 36, 62. Now we want the magnitude of L, the direction vector L. Okay. So it will be square root negative 1 square plus 2 square plus 3 square, which is square root 1 plus 4, 5 plus 9, 14. Substitute everything in this equation and we'll get it. So let's do it. 27 was the left side. OA came out to be square root 62. And square root 14 is the magnitude of L and cos theta. So by cross multiplication, these two will go down and become denominator here. So 27 divided by square root 62 square root 14 equal to cos theta. Theta is cos inverse 27 over square root 62. And if you want to write inside also, okay, you can write outside, no problem. Leave everything to your calculator. Just put this in your calculator and you will get the angle theta between the line L and position vector OA. What I got is 20, how much? 3.588. Okay, we want 3 significant figures, so it will become 23.6 degrees. This is the acute angle between the two vectors. Okay. What's next? Find the position vector of the foot of the perpendicular from A to L. So A to L. Okay. So let me copy the same thing here. So this is A, this is origin, and this was L. So we want to know the position vector of this, which is this O and this one. Let's give it an alphabet M. So we want OM. Let me go back there. 156 was the coordinates of point A. So 156. We know this is 0, 0, 0, though it is of no use. Okay. M. Let's assume that the coordinates of M are A, B, C, because they're asking us the position vector of foot of the perpendicular from A to L, which is M. So if we get somehow these coordinates, they will become the position vector with reference to origin, right? So now, since ABC lies on L, it will satisfy the equation of L. So let's see what is the equation of L here. 4. Okay, let me write here 401. Let me write equation of L again. 401 plus lambda negative 1, 2, 3. Okay, since point M is lying on it, it will satisfy this ABC will be satisfying this particular equation. So I can write here that A is 4 minus lambda, 4 minus lambda times minus 1, so 4 minus lambda. B will be 0 plus 2 lambda, just 2 lambda, and 1 will be 1, sorry, C will be 1 plus 3 lambda. If we find the parameter lambda, we'll get the coordinates, right? To find this, we should know that this line AM is perpendicular to the line L, right? And if we look back at this equation, the angle, if this is 90 degrees, theta is 90 degrees, cos 90 becomes 0. That means the dot product of A and B will be 0. So in this case, because we know that they are 90 degree to each other, their dot product will be 0. What I mean to say is this: AM, this vector, if I find dot product with vector L, it will be 0, because cos 90 is 0 and they are perpendicular. It is given to us. So we will do that now. So AM dot L is equal to 0. So we have to find AM first. So AM will be, let's write here, will be head minus tail. If I'm saying head is here, A, B, C is the head, so the vector AM becomes head component of x component of head minus x component of tail, which is 1 in this case, AM, and B minus 5, C minus 6, okay, which in turn can be written as, because we know them in terms of lambda. Here we have 3 variables, lambda is 1 variable, so it's better to convert them to in terms of lambda. So 4 minus lambda minus 1, 2 lambda minus 5, and 1 plus 3 lambda minus 6. So AM vector comes out to be how much? 4 minus 1, 3 minus lambda. This becomes 2 lambda minus 5, and here 3 lambda minus 5. Okay. This is AM. Now, what about L? L we already knew in previous part also. L was minus 1, 2, 3. That's what we'll use for L. So, okay. 3 minus lambda, 2 lambda minus 5, 3 lambda minus 5. This is AM dot minus 1, 2, 3. This is L. The dot product is 0. So, 3 minus lambda multiplies with minus 1 becomes lambda minus 3. Yeah. 2 lambda minus 5 will be 4 lambda minus 10. 3 multiplies with 2 lambda minus 5, 6 lambda minus 15 is equal to 0. Lambda plus 4 lambda is 5 plus 6, 11 lambda minus 3 minus 10 minus 13 minus 28. Did I write? Okay, it was 14. 28 equal to 0. So 14 lambda equal to 28. And that gives us lambda equal to 28 over 14, which is 2. That was our purpose, and now we can find here very easily what are the coordinates of A, B, C. 4 minus lambda is 2 now, 2, which is 2. 2 lambda is 2 times 2, 4. And 1 plus 3 lambda, 3 times 2. 1 plus 3 times 2 is 6. 7. 2, 4, 7. They are the coordinates of A, B, C. However, they asked the position vector of the foot of the perpendicular. Position vector becomes, so position vector will be 2i plus 4j plus 7k. Or if you want to write in column notation, it will be 2, 4, 7. That's the position vector of the foot of the perpendicular. Alright, next, hence find the position vector of the reflection of A in L. So let's look here. If I want reflection of A in L, that means this line will be extended, because for reflection we always draw 90 degrees from the point we want to reflect on the line we want to reflect in, and same distance on the other side also. So this becomes the reflection. Let's call it P, Q, R, and point is A prime. That's what I'm writing. So 1, 5, 6, 2, 4, 7, P, Q, R. Let's do them somewhere else. So 1, 5, 6 is A. It goes down, reaches L, where the foot coordinates are 2, 4, 7, and we want A prime, which we have assumed as PQR. I hope you will agree that this vector AM is exactly equal to vector, if this is M, M A prime. They are exactly same vector because their direction is same, their magnitude is same. So AM will be head minus tail again, 2 minus 1, 4 minus 5, and 7 minus 6 will be equal to A prime M, which is P, head is here, P minus 2, Q minus 4, and R minus 7. And now we can simply equate the x components with x and y with y and z with z. So 2 minus 1 is 1 equal to P minus 2. So 2 comes here, P becomes 3. What about Q? 4 minus 5 is negative 1 equal to Q minus 4. So it comes here, becomes positive 4, 4 minus 1, 3. Q is also 3. Third, 7 minus 6 is 1. 1 is equal to R minus 7. 7 comes here, positive 7, so R is 8. So question is, hence find the position vector of reflection of A. We have to find the position vector of this one, which is the component, the coordinates are 3, 3, 8. So the position vector O A prime will be 3i plus 3j plus 8k, or in column notation 3, 3, 8. All right, question number 10 and the final one. Okay, the constant A is such that integration of x square ln x dx is 4 when the limits are 1 and A. Show that A is equal to this. So basically they are isolating one A and keeping the other A on the other side. Alright, for that we need to integrate this one first. So let me write only integration. X square ln x dx. We'll make it equal to 4 later when we put the limits. I'm not writing limits right now. So we can see there is an algebraic part, there is one logarithmic part. So we will use our sequence LIATE to decide which one will be u, which one will be v in our formula. This one, integration of uv prime is uv minus u prime v. This is integration by parts. So the upper one becomes u, the lower one becomes v prime. So logarithmic, this is become u, and this is algebraic, this becomes v prime. So let's write here, u is ln x, v prime is x square. Okay, so this is our question. We have to write uv first. So our answer for this question will be u, which is ln x, v, but we don't have v. So to find v, we will have to integrate the v prime. So we'll have to integrate x square also. So v becomes x cube over 3. So that's what it will be. Let me write it in front, x cube over 3. So this is u, this is v, minus u prime. We have u, but we want u prime here. So u prime means we'll have to differentiate this. So u prime will be 1 over x. That's it. So u prime is 1 over x. V is, we just found out, x cube over 3. Okay, 1x will cancel with this, it will become x square. So what do we get here? X cube over 3 ln x minus 1 over 3. I'm taking this 3 out because it's constant, so I'll write just x square dx here. And x square dx is already integrated already. So it will be equal to x cube over 3 ln x minus 1 over 3 x cube over 3 and plus c. So finally we get, let me put the limits now, x cube over 3 ln x plus, rather minus x cube over 9 plus c, and limits were 1 to a, and this was equal to 4. Okay, so we can now substitute the values a and all. Okay, so it was x cube, this 3 left here. So now we'll substitute a and 1. So let me substitute a first. A cube over 3 ln a minus a cube over 9 plus c minus, I'll substitute 1, so 1 cube over 3 ln 1 minus 1 cube over 9 plus c equal to 4. So now c and c should be cancelled first. They have no use here because we're subtracting. Alright, a cube over 3 ln a minus a cube over 9 minus ln 1 is 0, so gone. We'll be left with this negative, and this negative makes it positive 1 over 9 equal to 4. Now let's look at our target. Our target is 1/3 on one side and a on one side. That means this a cube should be isolated on one side so that we can cube root both of them. So let's take which one is smaller? A cube over 9 is smaller, right? Yes. So I'm taking a cube over 9 common from these two. So what is left here? This is not a cube over 9. So to make it 9, I'll multiply this by 3 and multiply here by 3. Now it becomes 9. So if a cube over 9 is out, what is left? We're left with 3 ln a. It's matching here. Minus 1. And this 9, because it's a just constant, it will go with 4 on the right side. And now we'll simplify this. So a cube over 9 stays here because a cube we want to isolate. Rather 9 also we can leave. Just a cube stays here. This numerator becomes the denominator on the other side, and this 9 will become numerator. So 9 times, what is this? 9 times 4, 36, minus 1, 35 over 9 divided by 3 ln a minus 1. Okay, so this 9 and this 9 cancel. So it is 35 over 3 ln a minus 1. Now a cube will cube root this by putting an exponent 1 over 3 here. So we'll put an exponent 1 over 3 here. Well, and finally we are left with, because 3 and 1/3 cancel, it is 35 over 3 ln a minus 1 to the power 1/3. This is what we had to show. Exactly same. Okay. Verify by calculation that a lies between, this a lies between 2.4 and 2.8. Whenever they say verify, we do what? We bring everything to one side. So let's rewrite this as a minus 35 over 3 ln a minus 1 1/3, and nothing is left on the right side, equal to 0. Right? Obviously it will not be equal to 0, but let's see what happens. If I substitute 2.4 first, because they're saying prove that it is between 2.4 and 2.8. So let's say when a is 2.4, what happens? Put a equal to 2.4 minus 35 over 3 ln 2.4 minus 1 to the power 1/3. Is it equal to 0? It will not be equal to 0. If you use your calculator, you'll get minus 0.38 approximately. I'm interested in sign, not the number. Okay, it is less than 0. Can you see? It is not equal to 0. It is less than 0. Similarly, let's do when a is 2.8. So 2.8 minus 35 over 3 ln 2.a minus 1 1/3, which will not be equal to 0, but let's see what is it. I get negative, sorry, it's positive this time, 0.241124 and it is greater than 0. 1 was less than 0, 1 was greater than 0. That means if you draw a graph, if this is y equal to 0, somewhere it will change from negative to positive, right? So let me draw it the other way around. So it was less than 0 earlier, somewhere at 2 when x was, or a was 2.4. It was negative. When a became 2.8, it became positive. That means the root, which is the x-intercept, is somewhere between 2.4 and 2.8. So what do we write? We write here the change in sign indicates the presence of root between a equal to 2.4 and a equal to 2.8. That's what it is all about. Let's see next one. C part. Use an iterative formula based on the equation in part A to determine A. Correct to 2 decimal places. Give the results of each iteration in 4 decimal places. Okay, so let me rewrite what was the equation. A 35 over 3 ln A minus 1 to the power 1/3. Now, to find exact solution of this one, we start exactly in middle of the two limits we got. We know that our answer was between 2.4 to 2.8. So exactly in between them will be 2.6. And in iterative formula, this becomes our iterative formula. To use the iterative formula, we write n with the a which is not isolated and n plus 1 with the a which is isolated. This becomes our iterative formula. And we start with a1. And we have already decided that a1 will be 2.6, where we will start. That means a2, a1 plus 1, a2 will be 35 over 3 ln 2.6 minus 1 to the power 1/3. And we'll use our calculator. Before solving this, I've already done that, so let me write it. 2.6567, 2.6567, and there was 0 and some more digits, but I am rounding up because they have clearly said result each iteration to 2 decimal places. So 4 decimal places rather, 4. So I'm writing 4, I'm rounding off it to 4 decimal places. Okay. Now A3, next one, will be 35 over 3 ln. Now this x2, a2 becomes an 2.6567 minus 1 over 3. And now I'm fast forwarding this video so that you know the process. Every time whatever answer we get on the right side, we'll plug it in the next level. So let me do it. Okay, I stopped here because something happened. What happened that if I round them off, look here, if I round this to 2 decimal places, which they want is 2.66. Yeah. Next one will be 2.63. Here it is 2.64. This is 2.63. Next 2.64. And again 2.64. Whenever 2 consecutive iterations have same value rounded off to 2 decimal places, stop there, and that becomes your solution. For this particular question, A becomes 2.64. That's your final answer. Thank you for watching this video. If you like the video, please share with your friends and subscribe to this channel. I will be making many more videos like this. Thank you very much.